Hello, today is March 7th, and I'm giving this keynote address at Women in Communications Engineering in New Delhi in India. And I'm giving this keynote address virtually. And we have double celebration today. It's not only celebrating women in communications engineering, which is WICE, W-I-C-E, but it's also International Women's Day. And so I believe the International Women's Day is March 8th, and we are celebrating it today, March 7th. And this is a recorded presentation because what I usually do is record the presentation as a backup, but I almost always give a live presentation. So in about 6 hours, 6 to 7 hours, I will be giving this live presentation to a very large audience. And as I said, to celebrate both women in communications engineering, as well as the International Women's Day. I'm Bhavani Thuraisingam from the University of Texas at Dallas. I'm really honored and blessed to give this keynote address talking to so many women. And so a bit of history, I believe the International Women's Day was first celebrated around 1911, and that was 110 years ago. Even my parents, both my father and mother, were not born in 1911. So, it's such a long time ago, but 110 years later, and here we are celebrating International Women's Day. And we women have come a very long way, and we've got to be very grateful to the women who have come before us. But still, we have a very, very long way to go. And it's not just women, but also minority communities, all types of minority communities. We all have a very long way to go, and we call it diversity, equity, and inclusion. And I've given a number of talks on that topic as well. And so I'm going to share my screen, but I'm going to talk about two topics. One is to celebrate women and why a career in communications engineering for a woman. And second is a technical talk. That's my current research topic, which is integrating cybersecurity and artificial intelligence and applying it to one particular application, which is very relevant to communications engineering, and that is Internet of Transportation Systems. And I'm a computer scientist, and I belong both to the Computer Society as well as Communications Engineering Society, because they are both so connected to one another, because you can't have computing without communications and communications without computing. And so they are both so connected to one another. Okay, so let's see, I'm going to share my screen. Okay, WISE 2021. So my talk is why a career in communications engineering for a woman. And I'm going to then connect it to my research area, which is integrating cybersecurity and artificial intelligence. So what is unique about communication engineering as opposed to other areas in engineering and computer science? So many aspects of communications engineering are at the intersection, I believe, of electrical engineering and computer science. So you get the best of both worlds, because you get computing as well as you get electrical engineering, right? So I gave a version of this presentation at WISE, the Women in Communications Engineering, at the GlobeCom conference. And that was in December 2019. And that was in the big island of Hawaii. Little did we know at the time, right? December 2019, that just 3 months later, we will all be working from home. And now it is almost 15 months later, and we are still working from home. But in any case, It's sort of an intersection of electrical engineering and computer science. It's one of the more lucrative fields in engineering, and it's very high income because there's so many areas you can work. Internet of Things, Internet of Transportation, almost every aspect, right? Sensor systems, we need communications. Communications engineering researchers and developers are in great demand in government, academia, and industry all over the world. There's substantial funding in many agencies, at least in the United States, both in research and education, and this trend is expected to grow. And women still make less than 20% in many areas in engineering and computer science fields. And that is quite depressing. Although in some of the areas, especially in areas like data science, women make more than sort of 20%, more like 25-30%, I believe. But in areas like cybersecurity, so I work at the intersection of cybersecurity and data science, but in cybersecurity, it is only around 10%. And so on average, it's less than 20%. So even though we've come a long way, but still in the STEM areas and in particular engineering and computer science, we need to do so much more. Communication engineering helps humanity like wireless networking, and it's intellectually a very challenging field. And so I'm going to give you 10 reasons why a career in communications engineering for a woman. And so I believe I'm giving more than 10 reasons. So anyway, so 10 to 15, let's say 10 to 15 reasons. Given the opportunity, women can excel in any area, in engineering, computer science, just like men are excelling. It's just a myth when they say that, oh, women can't do science and engineering and mathematics and computing. No, that's just a myth, right? Given the right opportunities and the right motivation at home as well as in school, girls are just as good as boys. And that I speak from experience, right? I've been in the workforce for 40 years. And so I've taught men and I've taught women. And so they are equally good. Communications engineering is a very exciting field with so many innovations and developments happening so rapidly, right? Even when we talk about our smartphones, televisions, computers, communication is really at the heart of everything. It can be integrated with many areas, arts and humanities, natural sciences, social sciences, engineering, business, medicine, law, with a need for IoT and related technologies. Almost everywhere you go, right? Internet of Transportation, the whole Internet of Things, Internet of Medical Things, Internet of Financial Things. Communications engineering has many options from research and academia to product development to startups, and there's substantial funding. And millennial women, I think those women who were born, I believe, in the 1980s and beyond, have the flexibility and freedom to choose careers and have female role models in that field, in their field, that us baby boomers, because I belong to the baby boomer generation, we never had that. But still, I would say we are better. We are so, even the baby boom generation. So I was born in the mid 1950s. And so we are much better off than, say, those in, who came before me, those who were born in the 40s and 30s and so on. So everyone paved the way for the women who were going to come the following generation. In many research areas, you can work from home most days, making it ideal for women to have a family and career. But this is something, after COVID, most of us are working from home anyway, right? So this was sort of even before. I've been giving this talk for women in cybersecurity, women in data science, and women in communications engineering. And so I would say that this is a field where you can sort of work from home because a lot of it is sort of computing. But, almost any field, even medical doctors now are working from home. Of course, they also have to see patients. So in a way, that point after COVID, I'm, whether for men and women, I think, they can work from home in most careers. But, in many cases, women would want to work from home, even when we go back to work, once this pandemic is over, hopefully, I'm saying fall of 2021. Some of us would still want to, work from home and take care of our children and in some cases grandchildren. So anyway, so there are many reasons and continuing many communications. So yes, I've got 10 reasons. Communications engineering jobs cannot be overtaken by robots. That's very important because even we are talking about, say, medicine, right? Say surgery. Now we know we really need surgeons, but eventually I can see, there will come a time where robots could take over. In between you will have to have a human in the loop, but still there are many jobs. But it's not just sort of the manual labor that robots can take over, cleaning of the house and so on, but I would say, even sort of knowledge workers, right, their jobs could be taken over by robots. It's not just the factory automation jobs. But again, communications engineering and even computer science, we've got to develop the technology. We've got to develop sort of the robots and all the technologies. And so there will be a lot of opportunities, right? And then we've got to also analyze all the massive amounts of data coming from all these IoT systems. And so there will always, we've got to develop these algorithms. Communications and information security, it's a highly paid field. So I'm talking about communications. That's the particular area I work on. And I was really honored in 2009 to be given the Technical Recognition Award by the Communications and Information Security Technical Committee, which is part of the communications engineering. So it's not just communications and information security, it's also the communications engineering. It's a highly paid field with numerous job opportunities. And why not women take advantage of these benefits, right? And women can be financially independent with a career in communications engineering. And this is something I've been stressing, I would say, at least for the past 4 or 5 years when I started giving talks at various organizations for women about 5 years ago when I first started giving talks. Women can be financially independent, right? With communication engineering career. And I strongly, strongly believe financial independence means self-respect, less stress, and confidence. It is just amazing, wherever you are for women, please get financial independence. Why? Having financial independence is a must for every woman. I cannot stress that enough. I have read about women, being stuck in unhappy marriages because they cannot get out of it because they don't have the financial independence, right? Financial independence doesn't mean you need lots and lots of money. Sometimes women can't get out of marriages, even though their spouses are very high earning because they are not the ones who are earning. Financial independence means a woman being able to support herself, reasonably comfortably, right? So cover all the basic needs and be able to support herself and also her children. So that's very important. So financial independence is a must for every woman. Communication systems are everywhere, from north to south, east to west, anywhere in the world. Therefore, these systems can be hacked. You can make the world a better and safer place with cybersecurity, artificial intelligence, including addressing the major problems of violence against women and children with technology. Okay, so this is something. We have communication systems. We need to secure the system. We also need to protect. We need to do surveillance, but at the same time, to see whether the women and children are being abused and assaulted. And at the same time, we also need to protect their privacy. So there's so much that we can do. Okay, so advice to all the women in general: do not be undermined by others, right? That is, when they say women are not good in STEM, right? Never give up when others, even women, put you down, right? So, because, if you give up when others put you down, they are the ones who are going to benefit. But if you succeed, right, then what? Your enemies, are going to be very unhappy, right? I'm not saying that you want to have enemies or anything, but again, when other people put you down, never give up. You've got to stand up and do even better. Work hard, set goals, but be flexible. As life does, not turn out the way, life never turns out. I wouldn't say never, but in general, life does not turn out the way we want it to, right? Wouldn't we all love it if we can all live in, multi-million-dollar homes and we've got wonderful families and great children, but it doesn't work that way. There's always hardships. If somebody tells you they've got a picture perfect life, please don't believe it. When you're younger, you think other people have great lives, but no, everyone has got difficulties, right? Especially when you marry and when you have children, whenever there are two people, right, you've got conflicting goals, right? It's almost impossible to have two people to think exactly the same way, agree 100% of the time. So there's always a give and take, right? So you've got to be flexible. That's what I'm saying. Love your work, but also you need to enjoy life. So you've got to have a balanced life. Be a role model to the younger women and learn from the successful women, right? So you've got to be a role model. You've got to help others, and you've got to form teams. That's so crucial. You've got to have a strong support system. Get mentors. So mentoring is really important, even though you may get into, and another thing, even though you may get into administration, which is very important to support women, and I'll come back to that point in a minute, but you've also got to keep yourself technical and continue to do top quality research, development, and so whatever work you are doing. But it's important for women who want to do administration, please get into senior administration, because see, in an academic environment, only if you have several department heads, right, women, that you can select and you can become a dean. If you have, out of every 20 department heads, if you have one woman and 19 men, the chances are the dean position will be going to the man, right? And out of 20 deans, if you have 19 men and one woman, the chances are the provost or president position will go to the man. So in 20, if you have 10 men and 10 women, then the chances are, there's a 50-50 chance that the woman will get selected, right? So get into administration. That's the only way you can help other women, right? I mean, I wouldn't say only way. That's an excellent way of helping other women, but keep yourself technical. That's important. Never give up your technical strength. And suggestions for senior women: support women on issues of importance, tenure-related matters, right? You need to support the women, promotions and corporate boards. Connect women technologies with senior personnel, both men and women. Get them mentors so that they can mentor women and give advice on career development. Promote women for program committees, program chairs, and awards and fellows, especially IEEE fellows. I mean, there are still very few women with IEEE who are IEEE fellows, which is very important for our community, right? Communications engineering, computer science, electrical engineering, to become IEEE fellows. Venture funding, right? If you want to do startups, senior women who are who have access to venture, help the younger women. Promote women to take on administrative positions, very important, so that they can mentor junior technologists. That's what I mentioned, right? You need to have more department heads, women, so that you can become female deans. Introduce engineering education in elementary, junior, and senior high schools, right? You can't just have, just like we do in computing, we say computing from K through 12. Introduce computer science at a very young age. Similarly, introduce engineering. Engineering, I would say, is a little bit more challenging to introduce because, it's, programming is sort of more, developing software and code and so on. But engineering, you need some good mathematics, but some of the engineering principles, and explain to them what engineering is all about. And so engineering education really is very important. And for us, communication engineers, right? Who can forget Hedy Lamarr? Right? We've got this most wonderful role model. She's not only considered to be one of the most beautiful women in the world, but she's also brilliant. Why? Because she's the one who made Wi-Fi and Bluetooth possible for us, right? Because she developed this patent for radio spectrum frequency back, I think, in the 1940s. And she's also was a Hollywood star. And so she invented the technology. And because of her, now we have Wi-Fi, and we are all walking around with our smartphones, so that we can work on developing and securing the technologies that, when I say securing, that's, I talked to a security group recently. So we can work on developing the technologies and securing the technologies that, she started. And I got this photograph, by the way, that, hedylamar.com/photos. So this sort of finishes the first part of my presentation. And I hope that all of you all who are listening to my talk are motivated, right, to, to embark on a career in communications engineering, whether it be academia or whether it be industry. It's just it can be a very lucrative career. And as I said, as women, we must have a high-paying job, which is very important for our self-respect. Okay, so I'm not just talking only for the money, but intellectually it's challenging, and intellectually we'll be stimulated, and it's sort of both, right? They all sort of both go sort of hand in hand. Okay, so now I get to the second part, which is my research area, integrating cybersecurity and artificial intelligence. And so I use artificial intelligence / data science / machine learning, and one particular application, which is Internet of Transportation and Infrastructures, which is which can be appreciated by communication engineers, this particular application. That's why I chose, because I work in a number of different applications like healthcare and some other applications. So I chose Internet of Transportation as an application area. Okay, so my outline of my talk, integrating cybersecurity, AI / data science / machine learning. I'll talk about big data security and privacy, and then talk about some of our work on privacy-aware quantified self. And then I'm going to talk about two things. One is applying data science for cybersecurity, right? So data science can be applied for a number of areas like healthcare, Internet of Things, and finance and retail. So one application I'm focusing on is cybersecurity. And how do you secure these data science techniques? Because the machine learning algorithms, your data science algorithms could be attacked by hackers. And so how do you secure these techniques? Part 2 is going to be security and privacy for Internet of Transportation and various infrastructures. And part 3 is to apply part 1 to part 2. So application of security and AI for Internet of Transportation and infrastructures. Okay, so number of our sponsors funded this effort, and also my colleagues, Professors Alvaro Cardenas, Murad Kantajalu, Latifa Khan, and a former PhD student who is Dr. Raul Quinenoes, and a project coordinator, Ms. Rhonda Walls. Okay, so part 1, integrating cybersecurity, AI, ML, data science. First, I want to give you a little bit of flavor for data science / data mining. We used to call it data mining, by the way, and it's evolved into data science. And what are its implications for security and privacy? Without a doubt, we need data mining, data science for a number of applications, including security applications, right? We are applying it for counterterrorism, national security, cybersecurity, healthcare, but there is a privacy concern because now you can collect lots and lots of data, analyze, and that could violate the privacy. I'm going to give some examples. So I introduced the idea, I believe I introduced it, data mining, security, and privacy. There was a keynote address at the IFIP 11.3 in 1996 in Italy, Como, Italy. And then I gave another keynote address in Melbourne, Australia, Pacific Asia Knowledge Discovery Conference in 1988. And I published, I call it a landmark paper. Why? Because I was a program director at National Science Foundation in 2002. So and that spawned a new area of research. So when you are a program director, you fund many research activities. And of course, if you have money and then you fund activities, then people will listen to what you say. And so your paper gets a lot of references. That's why I call it landmark paper. Around the same time, researchers from IBM Almaden Research Center came up with privacy-preserving data mining. How do you do data mining or data science or machine learning and at the same time ensure privacy? It's challenging, but again, something I would say is better than nothing, right? So you have the original data. You don't want to divulge the original data that you have diabetes or you've got COVID, but you want to find out the results like certain ethnic group they are more susceptible to COVID or susceptible to diabetes. So the original data, you add some noise and random values and perturb, and then you take the modified data and then you modify the data mining process, and your end result should be the same, right? So that's the whole idea. And so when I joined academia, so I've had a 40-year career, 35 in cybersecurity and data science, started my career at Honeywell, and then I worked for a federal research lab, MITRE Corporation, and then for the government, National Science Foundation, and then I joined academia full-time, October of 2004. So we had a student, Dr. Li Liu, and she worked on privacy-preserving decision trees. Anyway, data mining, security, and privacy is exacerbated with what we hear now, big data, massive amounts of data. And they're collected and analyzed, so much of data now, right, with Internet of Things. So I organized a workshop, a National Science Foundation workshop in September 2014. It was Big Data, Security, and Privacy, and I presented the results to the Interagency Working Group in February 2015. Okay, so a lot of the papers I've referenced. And so as a result of that workshop, we started, so anyway, what did we discuss at the workshop? So big data management, security, and privacy. Lots of data being collected, right? So because of all these technologies, we can capture, we can process, we can collect, we can analyze, we can share data for a number of tasks, healthcare, finance, and so on, pandemics, and it also helps with security, right? So security tasks that we can apply data, data science, authentication, access control, anomaly detection, user monitoring, insider threat. So I'll give some examples on insider threat later on. So by analyzing all of this data, you can collect on the web, you can identify connections and relationships and disease outbreaks and homeland protection, whatever. But you want to protect the privacy. So collected data, you can anonymize by removing the identifiers of the records. But when you link multiple records, you could re-identify the person, right? So if you say that, in a group, let's say only one person is 60, everybody else is in their 20s. And then if you have a record, even if you remove the name, you can say 60-year-old and some other properties, and you know who the person is, right? So even if you remove the identifier, like the name or social security number, you can re-identify. So security tasks such as authentication, access control, they require detailed information, right? Multi-factor authentication would need what? Handwriting, or not just the password, it can also your voice. So lots of information is collected about people. And if this information is stolen, right, imagine the privacy breaches. And so we came up with a lot of directions. One is, of course, applying data science and so on for access control models. And so that's something I'm not going to discuss because, remember, when you have lots and lots of data, what sort of policies, access control policies should you enforce? And so data science techniques could help you, with coming up with the appropriate policies. So I'm not going to touch on that, but I'll talk about all of the other areas, privacy enhanced techniques, right? And applying data science, big data for cybersecurity, that's insider threat detection is what I'm going to talk about. And then a very, very popular area now in cybersecurity, which is adversarial machine learning or securing these machine learning techniques. Okay, so privacy aware quantified self, what does that mean? We have mobile devices, smartphones, they are prevalent computing platform, billions of users. And with the recent emergence of quantified self, there's a quantified self movement. So what is that movement? Sociologists and psychologists, right, they are talking about this quantified self movement because wouldn't it be wonderful if our smartphone can give us advice, right? That means lots and lots of information has to be collected about us. So wouldn't it be great if I open the refrigerator? I love chocolates, milk chocolates and vanilla ice cream. And so I just go to the milk chocolates and vanilla ice cream and I want to take that and, start eating. But wouldn't it be great if the refrigerator, tells me on my smartphone or refrigerator tells me, no, you cannot eat that. That's not good for you, right? It'll be great. But in order to do that, this Internet of Things, right, they've got to collect lots of information about us. As a result, privacy could be violated, because if that information is sent to my insurance company, right, and then if I get diabetes or something, thank goodness I don't have diabetes, or yet I should say, the insurance companies could get that information, and then they might say, oh, okay, we are not going to, give her insurance if she gets diabetes, okay? So, but by the way, I want to tell you that I'm really careful, right? Although I like vanilla ice cream and milk chocolates, I do not have it in my refrigerator at all. I never buy milk chocolates. I never buy vanilla ice cream. And so I have really no temptation to eat chocolates and ice cream. But in any case, right, so privacy could be violated, right? So, and I'm going to expand on that. Such data collection, sharing often being carried out, and it's going to be carried out without the user's knowledge, right? And it could be used, in inappropriate ways. So data collected by a device monitoring blood glucose levels might be used by an insurance company, not only to deny insurance coverage for a person, also the person's children and grandchildren, right? Because sometimes diseases like diabetes and cancer and so on, they could be hereditary diseases, right? So such privacy violations could easily get out of control if data collectors could aggregate financial and health-related data with tweets, Facebook activities, and purchase patterns and so on, right? You can have lawsuits and all kinds of problems, psychological problems. To address these growing challenges, we need tools. So yes, quantified self is a great thing, great movement, but we need tools for privacy-aware quantified self. And so we have come up with an approach. We call it privacy-aware, policy-based quantified self, and come up with a data management framework. So our smartphone is collecting health data, fitness data, location data, social media data, image, video, other data sources, and some of the data is going to the cloud, right? Because we can't store everything in our smartphone. So some data goes to the cloud and it's sensitive data encrypted, and some others anonymized encrypted. So through the cloud services, we can get the data. So essentially what we are developing is this privacy aware, policy based. So what we are saying is every step of the way, data collection, data storage, data analytics, data sharing, policies have to guide. Data collection, one policy could be you need to get the approval of the person before you can collect data about him or her. Data sharing could be you can share certain types of data, but you cannot share certain other types of data. So policies have to guide this entire process. And so policy-aware data collection, storage, access, analytics, learning, and sharing. So continuing with that, as we said, more and more data collected, the storage on the device will not be sufficient to store all of the data. So we envision an encrypted cloud storage components, right? I mentioned. So this is our privacy-aware quantified smartphone, mobile apps, data access framework, and some local data, some other data in the cloud. So based on the policies, access control policies, local apps running on the device will be given access to some of the collected data. When needed, these apps will be allowed to access some of the encrypted data. So data that you're not using often, it can go to the cloud. In some cases, you may not need to, like a 20-year-old person, you may not need to store the daily weight. But for a 60-year-old person, you may want to weigh that person daily, right? And in other cases, data may have to be deleted, right? So there have to be policies for deletion. That's another thing, right? Just because you have deleted doesn't mean that it's completely gone. So you've got to make sure that the data is gone. And we envision data sharing and analytics will be carried out using the services. And based on different scenarios, some data could be sent without modifications because they may not have sensitive data. Some will be sent after sanitization, randomization, and so on. Okay, so again, the main point is policies have to drive data collection, storage, access, analytics, learning, and sharing. Okay, now I go to the second topic, right? Not part two, but second topic. Remember 4 areas: big data security and privacy, privacy-aware quantified self, and now data science for cybersecurity applications. So we are looking in this particular case, data streams. Lots and lots of data are coming because whether we talk about sensor data for Internet of Things or whether we are talking about network traffic data, we are using past data to build a classification model. Predict the labels of future instances using the model and helps with decision making. Lots of data coming, and so I'll tell you the challenge, right? Big data streams, continuous flow of data, very common in our digital world, massive amounts. So what we do is that we build a classification model. But remember, we are not building one model. Because remember, lots and lots of data coming. So the concepts are changing. If you build one model, that model is not going to be there forever, right? The concepts are changing. So we are building an ensemble of models, a collection of models. And so some models get outdated, and so we throw it away. And then replace them with some new models. That's the challenge. That's the research. And then when the test data comes, right, if it's attack, it goes, we test it, we train the models, we test it, block and quarantine, benign traffic we store in some server. And so there could be a human in the loop, but these models are talking to each other and throwing away the models that are not valid any longer. So that's the whole idea. And we applied our technique to inside a threat. So we carried out two types of learning. One is supervised, one class supervised learning, support vector machine, one class support vector machine, and unsupervised learning, graph-based anomaly detection, because for a research, we tried both, and our unsupervised learning gave us better accuracy. But in any case, what happens is, there are all kinds of sequences of words that people are typing, right? And so you take I chunks, continuously data is arriving, so you break it into chunks and you develop an ensemble of models, right? So gather data from chunk I and extract features, apply these learning algorithms, the analytics, and then you have the ensemble of models. Old models could be thrown away and the new models are replaced, and they are replaced by new models. And then the I+1 chunk arrives, and then you extract features and test. And then if it's an anomaly, then you flag. And so that's the whole idea. And so you could say, okay, so what's the big deal, right? Training and testing. But that's the challenge. How do you train? Constantly data is arriving. So developing this ensemble of models, extracting the appropriate features, and also applying the right type of algorithms. That is the research. That is the challenge. Otherwise, it's just training and testing. But again, it is a major research area because, again, what is inside? Bad people could be inside an organization and pretend to be good people, or bad processes could be inside the machine and pretend to be good processes, right? So those are the processes that we've got to catch. And again, continuous data, massive amounts of data. So that's why we need to develop an ensemble of models. Now, what happens if our algorithms, our machine learning algorithms, are attacked? Then what's the point? Your machine learning could be used for cybersecurity. Machine learning could be used for healthcare, for medicine, for finance. Imagine that, that could be a huge problem, right? You want to give diagnosis, or a doctor wants to prescribe medicine, and doctor, uses the machine learning algorithm, and it's attacked, and it's telling, give the medicine X and not Y, but X could be very dangerous to the person, right? So it could be a chaotic situation. Lives could be lost. And so that's adversarial machine learning. Adversary is learning. It's watching what we are doing, learning and trying to thwart us. It's learning about our models, about our data. So adversary modifies data to defeat the algorithms. Understand adversarial learning. That is crucial. It's not concept drift. It's not online learning. Adversary adapts to avoid being detected. It could happen during training time, and that's data poisoning. It could happen during test time, modify features when data mining is deployed. And there is a game that is played between the data miner and the adversary. So you can see, just watch this, right? All the red squares are bad instances and blue circles are good instances. This line is the support vector machine boundary line. See what happens, what the adversary is doing, watching what we are working on, and it's going to try to thwart us by moving the red squares into the good area, so they will not be caught. but we've got to be several steps ahead, and we've got to figure out exactly what the adversary is doing. So that is our algorithm. Adversarial machine learning, threat model, test time deployment. Attacker modifies X to X prime, modify packet length by adding dummy bytes, add good word to spam email, add noise to an image. Okay, so black dash line is the standard support vector machine boundary. What we are trying to do is, look at this. All the red squares or crosses are bad. The green circles are good, right? So what the bad guy is trying to do is push more of this into the good areas. So if this is the support vector, it knows that this is the support vector machine boundary line. So it's trying to move more instances here so that they won't get caught. But we have to catch what the adversary is doing and move our boundary line here. The blue line is the adversarial support vector machine boundary line, classification line. So if you look at the situation here, more of the bad guys are getting caught. Why? Because so anyway, there are more of the bad guys, but we have moved our line here. So a lot of bad guys are getting caught because we moved our line. But how do we move our line? I mean, we can move our line right here. Then all the green, all the bad guys will be caught. But all the good guys, there'll be false positives, and that's not good. We don't want false negatives, and we don't want false positives. Both are bad. So that's the challenge. There's a lot of competition because it's a game playing that happens between us and the adversary. So we need to move our boundary line. It becomes a game, and that is a huge challenge. Okay, so we've got to move it and put it at the right location so that a sufficient number of bad instances are caught. It's impossible to catch everything, right? Unless, of course, we move the blue line right here. So we got some very promising results. And of course, we had to try for different, our paper describes the different types of attacks. We had a targeted attack, and then we had a free range attack. What I'm describing here is our solution to the free range attack. Okay, so paper describes the different types of attacks. So this particular area, adversarial machine learning, it is a very important area right now, okay, in cybersecurity. Okay. So part 2, security and privacy for Internet of Transportation and critical infrastructures. Okay, so that's the second part. Internet of Things, right? Our refrigerators connected to our cell phones, connected to our clocks and Wi-Fi and, ovens and stoves and emails and televisions and everything. That's Internet of Things. And that's the internet of sort of, you can think of it as home things. Similarly, transportation, the cars are connected to the trains, are connected to the trucks, are connected to the roadworks. So everything is connected to each other. Okay, so that's the challenge. So much of information. It's a good thing because the trains will know that the cars are there and they're talking to each other. We will avoid accidents, and roadworks means congestion. We will avoid congested roads, all of that. So that's Internet of Transportation. It's IoT, Internet of Things, major implications for transportation. Autonomous vehicles aim at improving day-to-day activities, such as delivering packages, improving traffic, and the transportations of goods. In the US, trucks alone carry an estimated 63.3% of freight of goods. AVs are not limited to ground vehicles, but also include aerial and sea vehicles with a wide range of applications. Levels of automation for AVs range from 0 to 5. And so ground vehicles, right? Ground vehicles are cars and trucks and trains. They have a lower level of automation, 2. Aerial vehicles have an automation of 4, like drones and airplanes. And then also you have sea vehicles, right? Submarines and ships and boats. Companies are investing heavily in autonomous vehicles. General Motors spent $728 million in research and development in 2018, with plans of increasing to 1 billion. So I need to get the numbers because 2018 is a long time ago. Get the number for 2019. And now we are in 2021, so I need to get the number for 2020. Why there is great potential in AVs the improvements it can do to the transportation industry, security processes. Security and privacy is a huge concern, right? Because imagine all these, trucks and cars and trains are communicating. What if someone goes and attacks a communication, right? Communicating. So you guys, communication engineers, it's work for you all, right? There's a lot of opportunities, but again, you need to look at the security. The communication can be attacked, and if that is attacked, right, there could be accidents, there could be chaos. So that is why security is very important, and as well as privacy. I'm going to talk about privacy a little later. Okay, so security autonomous vehicles, AVs evaluate the environment using a variety of sensors: camera, GPS, inertial measurement unit, LIDAR, radar, ultrasonic sensors. Previous research has shown sensors are susceptible to malicious tampering, IMUs are susceptible to sound waves, and GPS receptors are susceptible to spoofing signals. Vehicles should verify the veracity of sensor signals before acting upon them. So AVs, okay, sensor-based. AVs rely on sensors to evaluate and interact with their environment. 2. Inherited issues. Sensors are susceptible to GPS spoofing and transduction attacks, and they manipulate environmental physical signals like visual, sound, magnetic, and so on. And needed defenses, classical computing security, such as memory protection, cryptography, and authentication, does not protect against these types of attacks, right? So traditional, like we computer scientists focus on memory attack, memory management, and attacks to memory and so on. We do some binary code analysis. Those techniques may not work because it's new types of data. So due to the real-time constraints, right, no verification, because AVs trust and act upon sensor data without any form of verification, right? So it's real-time in nature. So it's a lot of challenges. So what did we do? So we developed a physics-based anomaly detector. You might think it's very straightforward, but I'll tell you it's not. I'll explain to you why. So the algorithm itself, right? We build a reference monitor. Reference monitor is that part of the system that is security critical, right? It performs security critical functions. So we use a physics-based anomaly detection, PBAD algorithm for ground and aerial vehicles. So the algorithm has 3 parts. We build a model offline of the AV's physical invariance, implementing an online tool to monitor expected and observed behavior to detect anomalies. So offline pre-processing the model, we do online verification, and if it deviates, right, they raise an alarm if significant residual difference exists between the executions, then it raises an alarm. So you might think, okay, it's very straightforward, right? Offline processing, developing the model, online verification, and then anomaly detection. But no, why? Because you have to build a model, and it's not straightforward. It's just not like a network traffic or a, other kinds of database data or something like that. You've got to build a model, physical model. The AV's invariants are calculated using well-known nonlinear models, a mathematical model for aerial and ground vehicles, right? Accelerometer, gyroscope, and magnetometer sensor data on the X, Y, and Z axis is used for the aerial vehicle. Z is, by the way, Z axis. Vehicle position and steering angle is used for the ground vehicle. So K is state, YK input sensor measurements, YK pre-process sensor reading, UK is commands for rotors, and X is pronounced exact is predicted states. LX, LY, LZ moments of inertia, M is mass, D is drag factor, B is thrust factor. So this is the model we are building of the physical system. So aerial vehicle, it's a physical system. We need to build a model. And this model is not like your network traffic. It is much more complicated, right? And so you need mathematicians, control theorists, and communication engineers, and so on to build this model, physicists. And then online stage is extended Kalman filter, right? So electrical engineers and control theorists, they use Kalman filter, and that is used to predict AV's physical behavior by estimating unknown parameters from noisy sensor input, right? So from known parameters, you've got to estimate the unknown parameters. Then we divide the algorithm into 2 sections. One is predicting, correcting the estimation, and then it's compared against the sensor data. Okay. So anomaly detection, we use an existing algorithm, CUSUM, C-U-S-U-M algorithm, is then used to detect the persistent attacks. An alarm is raised if the residual differences is larger than a predefined threshold. So it sounds simple, but actually when you get to do that, build this model and develop this Kalman filter appropriately for this particular model, and then develop this algorithm and then apply this custom. So several factors have to come together, and that's a challenge. Okay, so the physical implementation we did for aerial and for ground. For aerial, Intel ready-to-fly drone controller PX4 flight controller focused on detecting GPS spoofing and gyroscope attacks, right? These are, and detected after 0.2 seconds, while gyroscope attacks are detected after 1.5 seconds. Overhead is about 5.4%. Ground vehicles, right? We used, built on top of a Traxi Ford Fiesta, ST Rally Chassis controller, ROS Kineticam, focused on detecting visual attacks on the camera. Attacks detected after 0.1 seconds. Overhead introduced is 2.25%. Okay, so we did not do it for sea vehicles because we live in Dallas, Texas, and we don't have a ocean or boat, but we do have. We could have. We could have tested boats in we have got some rivers and some lakes, but we only did for aerial drones and cars. Each threshold produces a probability of false alarms of approximately 2%. So this was a very interesting experiments that we carried out. And so this sort of explains the security part. And of course, we cannot forget about privacy, right? Beyond the security of individual vehicles, the transportation sector could greatly benefit from a supporting infrastructure that allows communication between vehicles, motion sensors on lampposts, and surveillance cameras, to name a few, to help identify traffic jams, reroute vehicles, and increase vehicle safety, right? So without a doubt, we need all of these techniques, right? Internet of Transportation, we need to analyze all of this data because we want to avoid accidents and so on. But from a user's perspective, there are privacy concerns, right? So much of data is collected, so much of data, photographs are taken, and so our photographs may be taken. Let's say I am a smoker. I don't want people to take photographs of me inside my car and then send that to my insurance company, right? Or I may not want people to know where my location, where I'm, where I am, where I'm driving, right? So there are very serious privacy concerns, but yet we have to collect all this information and analyze. So legislators, engineers, and scientists should keep privacy concerns in mind as advances in IoT become more prominent in day-to-day activities. This will aid at improving the public perception, reduce hesitation from consumers, and increase the adoption rate of new technologies. So again, we need different groups of people to work together. So that is part 2. Now what I'm going to do is apply part 1 to part 3. Applications of security AI for Internet of Transportation and infrastructures. Okay. So 1, we said data science AI for transportation security, right? We talked about data science for cybersecurity, right? So how do you secure transportation systems? Internet of Transportation systems subject to attack, right? It's an example of a cyber physical system. Streaming data is being collected from such systems, including autonomous and in the future driverless vehicles. As transportation systems go electric, we need energy conservation. Okay, so the transportation systems, right, they are going more and more electric, right? So it can attack the system and then it can, threats to the security of such systems could cause massive damage, right? Accidents, loss of lives, and we have to conserve energy so it can play with the hackers can play with the energy levels, and then we might get stranded in lonely highways. So it's very dangerous. Data science, machine learning techniques are being applied to analyze data. Without a doubt, machine learning has got a lot of applications in transportation systems. They are being applied more and more, just like machine learning is being applied for practically every application. So can the stream analytics, remember what I mentioned earlier, ensemble of models. So can stream analytics learning being applied to, say, financial data and network traffic data and so on, can they be applied to transportation data, right? The main question is, we have to understand the nature, right, of the complex transportation data and adapt our stream analytics techniques, right, and apply them for massive amounts of heterogeneous data and also detect those security attacks. That is our main challenge. So we talked about developing an ensemble of models, applying this cybersecurity, applying machine learning to network traffic and network data to detect these attacks. Can we apply that to this sensor data? That is the challenge. Okay. Adversarial machine learning. That's, I remember, most important topic right now, one of the most important topics in cybersecurity. Internet of Transportation Systems will depend very heavily on data science, AI, ML techniques for various applications, including optimum directions, driving without a human in the loop, and many more. The adversary will be learning the models used by vehicles as well as learn about the data used in the training of the models. So adversary is trying to learn what we are doing. We've got to thwart the adversary. It becomes game playing between us and the adversary. Adversary will attempt to thwart the vehicle's learning process. Therefore, the learning algorithms have to adapt to thwart the adversary's actions. Eventually, it becomes game playing between the adversary and the vehicle's machine learning algorithms. Okay. Challenge: what sort of game will be played? Is it a zero sum? Is it a Bayesian game? Is it a Stackelberg game? So we really need to understand the data and how these, how the adversary is going to act and how we can combat the adversary. Research on this topic is only beginning. Remember, I talked about our cell phones and all the smartphones, all the information being collected, but we've got to ensure privacy. Same way, now we have a car, but it's not the social media data, healthcare data. We have radar, GPS, cameras, LIDAR, ultrasonic sensors. Some data encrypted in the cloud, and then we use cloud services to retrieve the data. Of course, we've got data collection, data storage, data analytics. Cars have to collect all this data, share with trains and share with trucks and so on. And so what we are saying is privacy aware, policy-based autonomous vehicles. That's what we are developing. We haven't developed it yet, by the way. We need to develop. So policy-based data collection, policy-based data storage, policy-based data analytics, and policy-based data sharing. So that's the future. That's why I put a question mark. Another area that is really, we need to think about is this whole area of trustworthy analytics machine learning. Meaning that one thing is that, okay, one area of adversarial machine learning is that the adversary is trying to thwart us, we are trying to thwart the adversary, and we are playing a game. On the other hand, there is this whole area called formal methods, right? Formal verification of systems. Can you do some of the stuff in hardware, right? Because it's probably, people think that it's less likely for hardware to be attacked, but hardware can be attacked as well. And so what about applying formal verification for the software, right? That whole area is trustworthy analytics, trustworthy AI, trustworthy machine learning, or trustworthy data science. So computations over big data may require massive computational resources, and organizations like automobile companies may use third-party services to outsource some computations. When a third-party server is used for computations, data could become available in untrusted environments. You can observe man in the middle during data transmissions or inside a threat from adversaries at the third-party location where computation is performed. In some cases, data owners may need to protect their data, requiring cryptographic guarantees about data security and integrity, computational output from these third-party services. And so we are conducting research in multiple directions. One is doing it in hardware. So Intel has come up with a chip such as encrypted stream data processing and trustworthy analytics using advancements in embedded hardware, SGX, to support trusted execution environments. So we need to apply some of these technologies, right? Trustworthy analytics can be applied to transportation infrastructures, transportation systems, and that's something, it's in the future, right? So we also need to look at formal methods for trustworthy analytics, and those formal methods techniques, can we apply those techniques to autonomous vehicles, right? That's something, I don't know much about, but I believe that formal methods is becoming more and more important now, especially with so many software systems. And so that's something that we've got to keep in mind, as well as apply to Internet of Transportation Systems. Okay, so now this is the picture for trustworthy analytics, our hardware. So this is the Intel SGX. You have runtime libraries and wrappers and encrypted code. And so your data analytics, machine learning algorithms, they are being carried out in special protected locations, SGX enclave memory. Okay, so that's really the heart of trustworthy analytics with respect to doing it in hardware. And the other aspect, as I said, is applying formal methods and verifying the software. So my last chart, and I think I've talked for about close to an hour, I believe, or just over an hour. So summary and directions, developments in security and AI, integrating cybersecurity, artificial intelligence, data science, ML, exploding everywhere, right? AI is being applied everywhere. And whenever you automate something, there are security problems. So security and AI are becoming very tightly integrated. Applications of AI for insider threat detection. Okay, so number of applications, AI, including in cybersecurity, intrusion detection, malware analysis, insider threat detection, and security for AI, right? So AI techniques could be attacked. And then I talked about privacy and of course, managing one's life activities, the quantified self, but privacy aware quantified self. So I'm stressing policies are at the heart of this whole movement, policy aware data collection, data sharing, data storage, and so on. At the same time, with the development of the Internet of Things, including Internet of Transportation systems and infrastructures, security and privacy solutions are being developed, mainly physics-based solutions. And as driverless cars become a reality, more and more of the autonomous vehicles will use AI machine learning techniques. So the challenge, how can we develop AI solutions, AI techniques for detecting malware, right? Malicious software, insider threat, whatever, in AV systems. So usually malware, right? So in the autonomous vehicle systems. And how can adversarial machine learning work, right? Attacker is trying to figure out what we are doing. We have to, overcome the attacker's tricks and strategies. So it becomes game playing. And how can we apply that to Internet of Transportation? And can we develop a privacy-aware, policy-based data management framework for Internet of Transportation and infrastructures? Remember, just like we had the smartphone, we have a car and data is being collected, LiDAR, radar, GPS, and so on. And so privacy-aware data collection, sharing, and so on. And can we perform trustworthy analytics? Can we come and bring in Intel SGX to carry out the analytics into the Internet of Transportation, or formally verifying all of the software, right? So that there are no attacks. So that's another direction that we need to explore. And as I said, there are numerous opportunities for substantial research. And that's something that all of you all in communications engineering, there's, Internet of Transportation, it's all about communication between sensors. So communication engineering is a major aspect, right? And so there are many opportunities for you all to conduct research. And so I would like to thank my colleagues, all our email addresses, Dr. Alvaro Cardenas, Professors Alvaro Cardenas, Murat Kantarjulu, Latifa Khan, and our former PhD student who did most of the Internet of Transportation work, Dr. Raul Quinones, and our project coordinator, Ms. Rhonda Walls. And so I'm going to stop sharing and just my parting words. And again, thank you very much for, listening to this presentation. And I hope that, I gave my initial part was sort of a motivating talk, right? Why a career in communications engineering for a woman? And I gave 10 reasons. Of course, I can think of many more reasons, but 10 major reasons. And then I also talked about what we women should be doing, senior women, junior women, we need to support each other. We need to form team. We need to get mentors. We need to mentor our junior colleagues. We have to develop a support system. That is really crucial because you need to have mentors who will be looking out for you, because when they are discussing promotions, right? Usually it's mostly men, so they promote the men. So if there are women right, who are your mentors, they will be there supporting you, right? And so they will be mentioning your names for the promotion. So that's very important. And so I talked about that. And then I gave a wonderful role model, which is Hedy Lamarr. Not only is she beautiful, but she's also brilliant. She developed Wi-Fi. It's because of her, she developed radio spectrum technology, and it's because of her that we have Wi-Fi. Then I talked about my research area, my current research area, which is integrating artificial intelligence and cybersecurity. And so there again, for communications engineering, there's a lot of opportunities, because remember, at the heart of Internet of Transportation systems is communication, because all of these systems, sensors, I mean, all of these systems have to communicate, right? Your cars have to communicate with the trains, with the roadworks, and so on. They all have to communicate, and the communication must be secure. But at the same time, you need to ensure privacy. So with that, I'm going to conclude my talk. And if you have any questions, you can email me. I had, I mentioned my email address, my first name dot last name at utdallas.edu. So it's bhavani.thuraisingam at utdallas.edu. And thank you very much for listening to my presentation. As I said, it's my backup talk. So before I give any keynote address or any major talk, I always record it and then send it to the conference organizer. And so I guess I will be seeing you all in about 5 hours from now, not in person, but virtually. And again, thank you very much for listening. Thank you, and wish you all the best for the future. Thank you very much.